Okay, let's talk about the Fibonacci sequence again. And I think I didn't pause it. I think you heard me telling my dogs to hush. Anyway, okay, so we know it's not the arithmetic sequence because we're not adding and subtracting to get we don't add and subtract the same number. I don't see a pattern in here. Okay, it's not the same, but do you notice that, look, those numbers are the same numbers of the sequence. 1, 1, get it? 1, 1, 2, 3, 5. So that's got to mean something, right? That's got to mean something. So how would we figure out, how would we do that? What is that sequence? Hopefully you took a little time to try and figure it out before you started this video. But anyway, here's the pattern. You're going to take the two previous terms, add those together, and that 1 plus 1 is going to give me that 2, right? Now I'm going to take these guys. 1 plus 2, what does that give me? That gives me 3. 2 plus 3, that gives me 5. 3 plus 5, that gives me 8, right? Okay, so we're going to add the previous two terms to get the next one. Okay, so this actually happens in the real world. Okay, Fibonacci sequence happens a ton in the real world. This is just one example. And figure 13. If we want to know how many paths are you can to go, how many ways you can go from A to B, and you're only allowed to walk along the sides or on the diagonals of the squares in the directions indicated by the arrows. Okay, so if I do that, I'm getting the Fibonacci sequence. I've got my one way to get there. Now there's two ways. I could go this way or I could go straight. Here, there's three ways. I could go 1, 2, 1, 2, 3, whoops, or I could go 1, 2. Okay, so there's three ways to get there. So I could keep going, and so my Fibonacci sequence would be I would go all the way to 377. So my pattern is the Fibonacci sequence. The Fibonacci sequence, and I don't have a picture of it, but there sunflowers are the Fibonacci sequence. If you cut through conch shells, that gives you the Fibonacci sequence. So if you really want to know more about that, just YouTube Fibonacci sequence, and there's all kinds of videos about the Fibonacci sequence. Anyway, but I just want you to be able to recognize that sequence. Okay, now let's talk about a geometric sequence. Instead of arithmetic, we're talking geometric. So to get to the next number in a geometric, you don't add or subtract. Instead, you multiply by a fixed number. And that fixed number is called a ratio. Okay, and if you are multiplying, that can't be 0, because multiplying by 0, you're always going to get 0. So that would be a sequence of 0, 0, 0, 0, 0, 0, right? So that has to be something other than 0. So we're going to talk about the ratio of each of these guys. Okay, so the ratio, so to go from 1 to 2, what am I going to multiply by? I'd multiply by 2, right? So let's look and see. To go from 2 to 4, I'm multiplying by 2. To go from 4 to 8, I multiply by 2. So I'm multiplying by the same number, that is 2, to go from one to the other. So I would now multiply 16 by 2 to get 32. And then multiply 32 by 2. I can change my number colors. Multiply that by 2 to get my 64. And multiply 64 by 2 to get 168. Okay, so it's very similar to the arithmetic sequence, except you're multiplying instead of adding or subtracting. So for our next one, how do I go from 10 to 30? I'm going to have a ratio of what, 3? I'm multiplying by 3. So I take each one and I multiply. To get to the next one, I'm going to multiply by 3. Right? And the last one is really hard to see because I covered it up, but that's a 7. So 7 times my 3 is also going to give me that geometric sequence. Okay, now notice that the very first example, this one right here, we could have written it as 2 to the 0, 2 to the first, 2 to the second, 2 to the fourth. Notice, see those numbers, 2, 4, 8, 16, 2, 4, 8, 16. Okay, the only one that seems to mess it up is you have 1, but just remember, anything to the 0 power was 1. Okay, anything to the 0 power is 1. So it could have been written as 2 to the n. 2 to the n. Okay, so this is on page 27 of your book, but I didn't make you buy the book since I wrote a little book for you. So anyway, okay, so we have bacteria that are sitting in a dish. We should be very comfortable talking about this after COVID. Anyway, we've got them sitting in a dish. The number of bacteria triples every hour. So following this pattern, find the number of bacteria in the dish after 10 hours and after n hours. So 10 hours, that's trying to help us figure out what the pattern is, okay? And then n hours, that's where we have to tell the formula, okay? All right, so let's do a little looking at some patterns. Okay, so we started off with 2, just 2 bacteria. There's my 2 bacteria. Then after the first hour, remember, the number of bacteria triples every hour. So after the first hour, we're going to multiply it by 3. So we get 6, right? So we would get 6. Then at the beginning of that second hour, okay, after the first hour, we're starting the second hour, we had 6 in there, okay? We don't have 2 anymore, we have 6. So now we're going to multiply that 6 by 3, okay? And so 6 times 3 gives me what? 18. So now we have 18. And so at the third hour, we're going to take my 18. So that's what this one was. There's my 18. And I'm going to multiply it by 3. And then the fourth hour, I'm going to take what I had before and multiply it by 3. Are you starting to see the pattern? Starting to see the pattern? So let's look and see how many 3s we have. After the first hour, after our first hour, let me use a different color. After our first hour, we have 1 3. To do the second hour, notice I have 2 3s. Third hour, I have how many 3s? 3 3s. See the pattern? Starting to see the pattern? So after 10 hours, I'm going to have 2 times 3, 3, 3, 3, 3, 3 times 3 times 3 times 3, 10 times. Okay, so now notice that we have, here's my 10th hour, I put the 10 there. So if that was an n, then it would be 2 times 3 to the nth power. That's sort of hard to read. 2 times 3 to the n. All right. Okay, so now, instead of increasing geometrically, so that means multiplying, we're going to increase arithmetically by 3. In other words, we're going to add 3. So instead of multiplying here, now we're going to be adding. So 2 plus 3. So the next one would be 2 plus 3 plus 3. Then 2 plus 3 plus 3 plus 3. Once again, we have 3 hours, we have 3 3s. 2 hours, we have 2 3s. So now, again, we want to know what happens after 10 hours. So it would be, what, 2 plus 3 plus 3 plus 3. How many threes? We would have 10 of them. So it would be 2 plus 3 times 10 would be the shortcut, right? 2 plus 3 times 10. So if we let that in, if we let that 10 right here turn into our n in the nth hour, it would be 2 plus 3n. So now, once you know that, I could say, well, how much bacteria is going to be in there after 24 hours? You could, once you have the formula, then you could just plug it in, right? All right. So that's looking at patterns, and we had some that are geometric and some that were arithmetic. And now we have a figurative sequence. So a figurative sequence is based on figures, right? It's based on figures. So based on geometrical patterns, most figurative sequences start with the number 1 as the beginning pattern, like this one down here. I have 1 dot, and now I have 3 dots, and now I have 6 dots. And notice I'm making pyramid with these 15 dots, okay? First thing, is it arithmetic? Like, let's see. So I'm going to add 2 to get to the next one, right? But to get from here to here, I need 3. To get from here to here, I need 4. So I'm not adding the same thing, right? So it is not, nope, it's not arithmetic. We have no common difference. We don't add the same thing, okay? Is it geometric? Are we going to multiply by the same number? Well, to go from here to here, I'd have to multiply by 3. To go from here to here, I'd multiply by 2. From here to here, oh, that's a fraction. Let's not even talk about that. Okay, so we know that that's not it. It's not going to be geometric because there's no ratio. Is it Fibonacci? Can I add these two together? That would give me 4. That would give me, the number here should be 4, and it's not. All right, so we know it's not the Fibonacci sequence. Okay. So how in the world are we going to figure out, what the next one would be? Okay. So it's called, we're going to use differences to figure that out. So notice, to go from 1 to 3, I went up by 2. And 3 to 6, I went up by 3. And 6 to 10, I went up by 4. Do you see a pattern? We could probably guess what the next one is, right? So I'm going to find the second difference. The second difference is, I notice that to go from this number to this number, I'm adding 1. To that one, I add 1. From here to here, I'm adding 1, right? So I eventually get to a common difference. So I eventually get to this common difference, but it's not on the first go round, okay? It's not on the very first try. So you have to get to the second difference to find something that's in common. All right, so we're going to use difference to find this pattern. This is assuming that the pattern continues the same way, okay? It's not going to do anything weird out there, okay? So we got to figure out the next 3 terms. So hint, finding the differences may be helpful. Okay, so let's find the first difference. So the difference is 5, then 7, then 9, then 11, then 13. You can probably see the pattern already, but let's do the second difference, and we find out that, okay, I'm going up by 2s. So to get this next number, right, what am I going to add? So to go from 35 to 48, I added 13. So I'm going to add 2 more to that 13, right? I'm going to add 2 more to that. So that would give me what, 15? So that's going to give me 15. So I'm going to add 15 to my 48, and that's how I got 63. All right. So now what am I going to add? I'm going to add 2 more, right? So that's going to give me 17. So 63 plus 17, that's going to give me 80. All right. See the pattern? So now I'm going to add 2 more to that. So I'm going to be, let's see, that's going to be 19. So I'm going to add 19 to my 80, and I get 99. Okay. So when you first look at this, you may not see the pattern. Okay. But if you find the second difference, if you find the difference between them and you find that pattern in the difference by finding the second difference. So let's look at this guy. All right, this next one. I find the first difference. 6, 11, 19, 30. Whoa, that's weird. I don't see a pattern there. Okay, I saw a pattern here. I saw, okay, up here, oh, I'm just going up by 2s. But I don't know. What am I going up by? Let's look and see. My second difference is 5, 8, 11, 14. Now I'm starting to see a pattern. Do you see the pattern? To go from 5 to 8, I needed 3. And 8 to 11, I needed 3. Okay, so my pattern is on the third difference, right? So this is my, I'll write it over here. This is my first difference. This is my second difference. And there's my third difference. Holy moly, I have to go to the third. Okay, so to get the next one, I'm going to, what, I've got to add 3. I've got to add 3 to that guy. So that's going to give me, what, 17. And then I've got to add 17 to that guy. And then, let's see. Yeah. And then I got to add 17 to that 444. So, whoops, sorry. 17 to the 44. So now I know then I've got to add the 17 to the 44 to get 61. And that is what I'm going to add to 111 to get the next one, 172. Okay. So let's do that again because it's, you have to think this thing through. Okay. So I know that my third difference is 3. So I need to add 3 to this guy. So when I add 3 to him, I'm going to get 20. Right? So I'm going to write it out and then I'm going to erase and then show you again. Okay. So that means I'm going to add 20 to my 61. So 20 to 61, what's that? 81. So then I've got to do 81 added to 72 to get that next one. Okay. So let me erase the pink and then I'll show you. Oops. Right. So that's how I got 253. Let me do that again. All right, because I've got one more that I've got to do. Got to add 3 to that. So that's going to give me 23. And then I've got to add 23 to my 81. That's what, 104. And then I add that 104 to the 253. And that's how I get my final number. There we go again. So 357. Okay, so this one, again, you want to do a smaller version, a lesser problem first before we get to this one. Okay, so if you need practice, we're going to practice these in class, but we're going to start with those and then we're going to end up with these. Okay, and I'm not going to go to a fourth and fifth difference. You could, but we're not going to. Okay, last problem. Okay, so again, this is a figures, right? We're talking about figurative sequence. So the figure below shows the first 3 figures of an array of sticks. Okay, so notice that this is sticks. It's not matchsticks anymore. It's just sticks, so like craft sticks. And so we want to find out how many sticks are in the 7th figure and then the nth figure. So the nth figure, once again, we're eventually going to get to a formula. Okay. All right. So first thing I'm going to do is try and figure out if I have a difference. Okay. So 4 to 12, that's going to give me 8. The difference is 8. 12 to 24, the difference is 12. So this is not exactly the same. Okay, so I'm going to have to go to my second difference, and I have 4. Well, I don't know if I don't know if the next one is 4 because I don't have enough information, right? So I'm going to draw the next figure. So I drew the next guy, okay, based on the pattern, and I counted how many sticks are in there. So there's 40 sticks. So you may want to pause this video so you can draw it for yourself, okay? So there's 40. So now I'm going to see if that gives me a common difference. So from 24 to 40 is 16, and yes, that gives me a common difference. Okay, so I could then use common differences to get the 7th figure, right? So that's what I'm going to do. I've got my common difference. Notice that I'm going up by 4s. So I went up by 4. I didn't actually show that. Maybe I should do that. I'll show you that this common difference is 4. 4, 4, 4, 4. All right. So I did exactly what I had just been doing at the example before this one. So I know I'm going up by 8 here. I went up 12 here. I'm going up 16 here. So I'm going to add 4 to that. So that's going to give me 20. So 20 added to 40 is going to give me 60. And then my common difference again is 4. So I'm going to go up to 24. I'll add 24 to 60, get 84. Then I add 4 to my 24 to get 28. And that's what I'm going to add to 84 to get 112. Okay. So that works great. The problem is they want to know what the nth one is. What the nth one is. Okay. So let's see if we can come up with a pattern. Oops. Sorry. Okay. So let's come back up here and look. I'm not going to look at the first one. We can come back and look at that one. But look at this one. I'm looking at my horizontal. Let's see if I did my horizontal. Here's horizontal sticks. So I've got 6 of those. Remember, this is the second figure. Okay. So whatever my formula is, I'm plugging in 2 into that formula. Okay. Because it's my second figure. So to figure out the horizontal, I've got 2. I need 6, right? So it's 2 times 3 would give me how many horizontal ones I have. Let's do the vertical. 1, 2, 4, 6. Once again, I could get that by 2 times 3. Let's look and see if it works in the third figure. Again, this time I'm going to be plugging in a 3 because it is my third figure. This would be my first figure, right? And we'll talk about that one in just a second. But the third figure, once again, let's do horizontal. So I've got 3, 3, 3, 3. Oh, how many is that? 3 times 4. So my horizontal is 3 times 4. That gives me 12. And then my vertical, how many do I have? Same thing. 3 times 4. That gives me 12. So this is my fourth one. So my fourth figure. So if I use the pattern, it would be, notice 3 times when it's the second one. When it's the second one, it's 2 times 3 and 2 times 3. When it's the third one, 3 times 4, 3 times 4. When it's the fourth one, it'd be 4 times 5 and 4 times 5. So for the 7th one, it would be 7 times 8 plus 7 times 8, or 56 plus 56. So that gives me 112. So I could do it that way. Okay, now let's talk about what if it was in? What if it's in? So if it's in, okay, notice if, let's look at this one. Yeah, let's look at this one. So let's say that instead of 2, let me get an orange. Instead of 2, whoops, that's not what I wanted to do. Here we go. Instead of everywhere there's a 2, I'm going to put an in, right? So it's going to be n times, what is this guy compared to the orange guy? Notice this one, that 3 is just one more than 2, right? 3 is just one more than 2. Let's come over here and see if that's the same thing. If this is my n, because it's my third one, is 4 one more than 3? Yep, same thing here. That 5 is one more than 4. So if I let this be n, this one is going to be one more than that, n plus 1, right? All right. So our formula could be this n times n plus 1, and I have it twice, right? I have another one. N right here, there's my n, and there's my n plus 1. So, and then I just add those guys together. N times n plus 1 plus n times n plus 1. Okay, now you algebra people, and that's perfect. That's great. We have our answer. If I plug in, if I want to know the 200th figure, I could just put 200 wherever I have an n, right? But algebraic people, and you guys have done algebra so long, you might go, oh, wait, I can simplify that, right? I could do it 2 ways. I could say, look, I've got 2 of these guys. 2 of these n times n plus 1. So I could write it as 2n times n plus 1. Or I could keep simplifying and get 2n squared plus 2n. All 3 of these are the right answer. Okay, because any one of them is going to give you 112 if you put in 7, or it's going to give you 4 if you put in 1. It's going to give you 12 if you put in 2. All of those, any of those would be the correct answer. So that is the end of this section.